Myself Mohammad Rafiq, Assistant Professor, Department of Technology from Nehru Institute of Technology. Today we are going to discuss about a topic from engineering graphics, engineering curves, cycloid. Now we will discuss about the course objectives. We have 5 different objectives for this course. The very first objective is to construct the engineering curves. We have different type of engineering curves used in engineering applications. And next to that, we are going to draw freehand sketch of simple objects and advanced objects too. So this freehand sketching help us to draw a basic design of a component which we are going to design. Next to that, we are going to draw the orthographic projection of solids and sectioning of solids. Orthographic projection deals with drawing the front, top and side view of a particular model or an object. And next to that, we are going to draw the development, the fourth objective, course objective. Development is nothing but converting a 3-dimensional shape into 2-dimensional shape. Okay, and next to that, finally, the fifth objective is drawing the isometric and perspective projection of the solids, what we have studied in the earlier courses. Engineering curves, the curves which are used in the construction of engineering products, or we can say development of engineering products, which has been obtained by means of cutting a cone at different positions. So, for example, ellipse, parabola and hyperbola are the basic curves that we can obtain by means of cutting a cone at different positions of the solid. And advanced curves, or we can say name them as special curves, cycloid, epicycloid, hypocycloid are few examples which has been used in the construction of engineering curves. And next to that, we have advanced curves like involute, spiral, chart, etc. Defining a cycloid, a curve that is generated by a point on the circumference of a circle when it rolls over a horizontal table without any of the slipping. Okay. So, identifying the question, we will have a circular object named in the question. For example, a ring, a roller or a coin can be said as an example for a circular object which is being rolling over a horizontal table, or we can say a flat surface without slipping. Now, the curve is getting generated by a point on the circumference of the circle when the circular object makes one revolution without any slipping, that we call it as cycloid. Some practical examples of cycloid are pumps and we can say straight linkages are typical examples of cycloidal curve, and apart from that, gear teeth are actually designed by means of cycloidal curve. Now we will see a problem. So a ring of 40 mm diameter rolls over a horizontal table without any of the slipping. A point on the circumference of the ring which is in contact with the table surface in the beginning and after one complete revolution. Now we need to draw the path traced by the selected point in the circumference of the circle. Now we will go to the problem. Very first thing what we have to do is we have to draw a circle according to the given diameter in the problem. So for example, if it is 40 mm diameter, we need to draw a circle, and next to that we have to draw a straight line touching the circle at the bottom, or we can say tangent to the circle. So this line measurement can be calculated from the formula pi into d, which is nothing but circumference of the circle, and next to that we are going to divide the circle into 8 equal parts. So the reason behind dividing them into 8 equal parts, where we are going to get more number of points so that the curve joining will be very smooth and clear, and divide it into 8 equal parts and name the curve in the anti-clockwise direction with numerical values, for example 1 to 8. Okay, and next to that we are going to draw a horizontal line from the center and divide the center line into 8 equal parts and name it as C1, C2, C3, C4, C5, C6, C7, C8, which denotes center 1, center 2 to center 8. And after that, what we are going to do, we are going to draw horizontal line passing from all the points, and finally we are going to cut arcs by selecting the center, all the centers, and keeping the radius of the circle as the radius for cutting the curve. Now after marking all the points, we are going to draw a smooth curve passing through all the points. So where you can see the points will be named as P1, P2 till P7 and P8. Now if you join, you will get a cycloidal curve. So here we come to the course outcome. So after completing the engineering graphics course, we will be have a very good idea about the BAS convention and specification for creating an engineering drawing and construct conic curves, involute and cycloid. These are the two references, Parthasarathi and Velamurali of engineering drawing, published in the year 2015, and Venugopal K and Prabhuraja V, engineering graphics from New Age International, published in the year 2008. Here we have an assignment question. A coin of 50 mm diameter rolls over a horizontal line for half and revolution clockwise. Draw the curve traced by the point on the circumference of the circle, drawing tangent to normal on the generated curve. Thank you.